All right, so here is the next question. This series, does it converge absolutely? Does it converge conditionally? Or does it diverge? So basically, the intuition here is that since it has factorials, then the kind of the only tool that we have to work with factorials is essentially the ratio test. All right, so that's why we're going to apply the ratio test. So let me write the series again. Minus 1 to the n plus 1 factorial times n factorial divided by 2n plus 1 factorial. All right, so we're going to find the ratio test. Ratio test. And according to the ratio test, I need to find the absolute value of the ratio an plus 1 divided by an. So which means, well, the absolute value, well, basically kills the negative 1 to the n. Then an plus 1 is the same formula, only instead of n, I should write n plus 1. So this is going to be n plus 2 factorial times n plus 1 factorial divided by 2. Well, n becomes n plus 1, so it becomes 2n plus 2 plus 1 2n plus 3 factorial, well, divided by an, and this is an, so I just need to multiply by the reciprocal, so 2n plus 1 factorial divided by n plus 1 factorial times n factorial. Okay, so let me kind of group together similar terms. So I'm going to group together this n plus 2 factorial and n plus 1 factorial, right? So n plus 2. Let me just do one of them. The other two are similar. So n plus 2 factorial is the product of numbers from 1 until all the way until n plus 2. So there's going to be n there, there's going to be n plus 1 there, and there's going to be n plus 2 there. While n plus 1 factorial is the product of numbers from 1 all the way up to n plus 1. So these are going to cancel out, and the remaining part is just n plus 2. Okay, so basically n plus 2 factorial divided by n plus 1 factorial is going to be just n plus 2. Now, by the same logic, n plus 1 factorial divided by n factorial is going to be n plus 1. And by exactly the same logic, 2n plus 1 factorial divided by 2n plus 3 factorial is going to be 2n plus 3 divided by 2n plus 2. All right, so now we've got to find the limit of this thing, and in order to do it, we've got to divide by n squared in the numerator and divide by n squared in the denominator, and this is going to be 1 plus 2 over n times 1 plus 1 over n divided by 2 plus 3 over n here, divided by 2 plus 2 over n here, and the limit, whatever anything over n just goes to 0, and the limit of this is basically 1 times 1 divided by 2 times 2 is just 1 quarter. 1 quarter is less than 1, so this converges absolutely.